and I'm going to talk about or start about what UVC actually is. We all know light. This is the part we can see, and there's a whole part in the UV range we can't see. The most important thing here is the shorter the wavelength gets, the more energy you can transfer with it, or the more energy it contains. The UV light we normally talk about is UVA and UVB, the light from the sun. UVA is the sunlight that reaches our Earth, and it also has positive effects. UVB is the part that's partly blocked by the ozone layer. It's also the part of UV light where we use sunscreen for. It's more damaging, worse for your skin than UVA. And then you have UVC light, which is also produced by the sun, but it's completely blocked by our atmosphere. I'm going to talk mainly about UVC light, because this is the disinfection light and the chemically active UVC light. And the reason we use it is quite simple. This short wavelength, we generally use 254 nanometer, is right in the middle of the peak of absorbance of the DNA. And that corresponds really well to how well you can kill bacteria with it, for instance, E. coli. We make this in special lamps. I think you're a bit too young to still remember the old fluorescent lamps that were everywhere. But the lamps we use are similar in operation. It's a gas discharge lamp. The main difference is for visible light, there's a phosphor on the inside of the lamp that transfers or makes the UV light into visible light. The lamps we use don't have this phosphor layer, so they produce pure UVC light. There's a filament, and there's a tiny amount of mercury in the lamp to emit the UVC light. This is a very small amount. And there's a gas that fills it. And there are different lamps. You have medium pressure lamps, so the gas has a slightly higher pressure. Those you can get in higher powers. You have low pressure lamps, where the gas pressure is lower, and these are more efficient. So you can have more output or more efficiency, depending on how the lamp is produced. This difference between medium and low pressure is quite important and quite large. The purple line you see here is the emission line of low pressure lamps. The orange line is the emission line of medium pressure lamps, and these are the same scale. So when you integrate these lines, you quite quickly see that a low pressure lamp for the same amount of light produces more light than a medium pressure lamp does. However, the medium pressure lamp produces a few more wavelengths, which you can use for other things. Quite often also this can cause unwanted reactions. So medium pressure lamps are mostly applied in situations where you need really compact high intensity systems. Our strongest low pressure lamp is around 600 watts. The strongest medium pressure lamps you can get in the market go up to 10 kilowatts. So you get a lot of light out of a really small lamp. There are also emerging lamp technologies, currently mostly LED. In the visible light market we have seen, I used the example of fluorescent lights. We still know them from when we were young. The whole normal lighting market has been taken over by LEDs. For visible light, these are extremely efficient, cheap to produce, easy to integrate. The same is happening to a much lower degree in the UV market, where UVC LEDs are being developed. The problem is, on one part, that UVC light is really strong light, so it's much more difficult to make something that can handle that light. So what you see with LEDs, that the output power is really low, and particularly the efficiency is really low. So if you look at our 600 watt lamp with a 35% electrical efficiency, you produce around 200 watts of usable UV light. The best LEDs on the market now are around 2 watts, and they have an efficiency of around 8% maximum, which means you only produce 0.16 watts of usable light. For now, if you want sustainable easy to applicate and validated UVC technology, the classical lamp technology is still very dominant, and we expect it to stay like that for a while.